Hello, everybody. Okay, so here we are with 7.5, solving radical equations. Take notes. Hopefully you're keeping up with the homework. Okay, 7.5, solving radical equations. All right, so how to cancel square root. So let's start with that. Square root as opposed to cube root. Okay, so for any non-negative real number, a, so the real number is a. If you have this, right? Well, if I square this, then I end up with just a. Okay? So that's what you would do to cancel out a square root. You would just go ahead and square. Okay? So in general, if you don't have the square root, if you have like the nth root, like cube root or fourth root or fifth root, okay? So if this is a real number, then, oh, here, where's the a? There it is. Okay. Then if you raise this to the nth power, the power and the root will cancel out and you will have a. Okay. All right. So solving radical equations. Okay, so solving radical equations. So what you want to do is definitely isolate the radical. If you have more than one radical in the equation, then pick one and isolate it. So choose one if more than one. Okay, doesn't matter which one you isolate. It's going to take the same amount of work anyway. Okay, and then you can cancel its radical by squaring both sides. So you square both sides, or n power, whatever it is. Okay, square both sides if it's a square root. Okay, and then you repeat this process. So if you have more than one radical, then you just cancel one radical at a time. Okay, so get the radical by itself. Like, let's pretend it's a square root. Okay, so get the square root by itself, square both sides, you get rid of it, right? And if you have more than one, then repeat this process. Go find the other one, isolate it, square both sides, and you get rid of it. Okay? So repeat process until all radicals are gone. Okay? And then you want to check your answers. You might have answers that give you imaginary results, so you want to not include those answers. Okay, so check your answers. This for square root, this is principal square root. So only positive answers. Okay. And also no negative. No negative results inside. Okay. Or else you end up with imaginary. Okay. So let's take a look at some examples. Let's take a look at this one. Let's go ahead and solve. Square root of x plus 3 equals 4. Okay. All right, so I'm going to bring this down here so we don't lose the original problem. Okay, so we see here that the square root is by itself, so we don't have to isolate it. It is already isolated. Okay, so I need to get rid of the square root. So what I'm going to do is square both sides. So I'm going to square that, and I'm going to square that. And when I do that, the square and the square root will cancel. Okay? And then I get x plus 3 on the left, and I get 16 on the right. And then the rest is standard solving here. Okay? So subtract 3 on both sides. And x is equal to 13. But we need to check. So let's go back to the original problem. And here. So the original problem up here, square root x plus 3 equals 4. So we're going to go ahead and plug our answer in there. And we're going to check, does this equal 4? Okay, so here I get square root 16, and I get 4. And so yes, it does check. Okay. All right, let's try another one. Let's take a look at this one. Let's solve. Square root 3x plus 1 equals x. Okay. So again, we still only have one radical, so we're going to isolate this here, this radical. So that means we're going to have to subtract 1 on both sides. Okay, but before I do that, let me write the problem down here. Okay, so isolate the radical. So let's subtract 1. And then once you isolate the radical, then you can go ahead and cancel the radical. And we do that by squaring both sides. Okay, so this one, same process. It's just that over here on the right-hand side, it's going to be a little different when we square. So x minus 1 squared, that means x minus 1 times x minus 1. So if you need to go off to the side and multiply that out, then go off to the side and do that. Like go off to the side over here and figure out your x minus 1 times x minus 1, right? Distributed property. Okay, I'm going to go ahead and use the shortcut, x squared minus 2x plus 1. Okay, so now I end up with a degree 2, a quadratic. So I'm going to set this equal to 0. So I'm going to subtract 3x on both sides, and then I'll subtract 1 on both sides. Okay, so let's subtract 3x on both sides. And they cancel out. And then I'm also going to subtract 1 on both sides, and they cancel out here. Okay, so we're going to set it equal to 0. All right, so here I get x squared minus 5x. Oh, 1 and minus 1 cancel. So we get x squared minus 5x. This is some nice easy factoring. I'm going to factor out an x, and I'll be left with x minus 5. And then I take each factor, set it equal to 0, and solve. This one's already solved. This one I have to add 5. So x equals 5. I'm not boxing my answers because I have to check them, but I'll put little clouds around them. All right, so let's go ahead and check. All right, let's check 0 first. Where's the original problem? Up here. So 3 times 0 plus 1, and then plus 1 equals 0. Okay, so let's plug in 0. So we're checking x equals 0. So square root 3 times 0 plus 1, and then plus 1 equals 0. So this is 1 plus 1 equals 0. 1 plus 1 equals 0. 2 equals 0. No, it does not. Okay, so nope. Okay, so this one is not going to be the solution. Let's check 5. All right, so let's go ahead and check the other one. X equals 5. So square root 3 times 5 plus 1 equals 5. So that's 15 plus 1 equals 5. And then here we get 16, and then plus 1 equals 5. Here we get 4 plus 1 equals 5. And here we get 5 equals 5. Yes. Okay. All right, so x equals 5 is our only solution. Okay, so now I'm going to go ahead and box it. Okay, so x equals 5. All right, so let's just go back and look at this. So here, here's the problem, and we only have the one radical, and you see here that we isolate the radical, we subtract 1 first on both sides. Okay, and then we can go ahead and square, because remember the square and a square root will cancel each other out. Okay, let's just take a look at another example. Let's go ahead and solve. Square root 3x plus 8 equals 2. Okay. So I'll write it over here. So again, we need to isolate the radical. So I'm going to go ahead and subtract 8 on both sides. And over here, they cancel. So we get square root 3x equals to negative 6. And then I'm going to go ahead and square both sides to cancel out the radical. Okay. And I end up with 3x equals to 36. Divide both sides by 3. And x equals to 12. Okay, so let's go ahead and check this answer. I'll check up here. Okay, 12. So square root 3 times 12 plus 8 equals 2. So here we get 36 plus 8 equals 2. Square root of 36 is 6. 6 plus 8 is 14. 14 does not equal to, nope. Okay. So here we would say no solution. Okay. Okay. Let's take a look at cube root. Okay. So let's take a look at this one. Solve. X cubed plus 7 to the 1/3 power equals x plus 1. Okay. All right. So here, let me write it down so we don't lose the original problem. Okay, so remember here, 1/3 power is the same as cube root. So let me rewrite it with the cube root instead of with the fraction exponent. Okay, and then here, the radical is already by itself. So I'm going to go ahead and not square it, but I'm actually going to cube it. Okay, because remember, these have to match. Okay, in order for them to cancel. Okay. So when I do that, I am left with x cubed plus 7 equals, all right, so we need to go off to the side and do this. All right, so x plus 1 times x plus 1 times x plus 1. This part over here, I know this is going to be x squared plus 2x plus 1. And then I have to distribute that. Okay, there is a shortcut, but I don't believe I went over it, so I don't want to use the shortcut that I haven't shown you guys. All right, so x cubed. I'm distributing here, so I'm doing x. I'm distributing this x to these three terms. So x times x squared is x cubed. X times 2x is 2x squared. And x times 1 is x. All right, and now I'm going to distribute the 1 times that, 1 times that, and 1 times that, which is going to just give me x squared plus 2x plus 1. All right, and then combine like terms, so I get x cubed plus 3x squared plus 3x plus 1. Okay, so that's what we get on this side, on the right side. So let me write that down. X cubed plus 3x squared plus 3x plus 1. Okay. And so here we have a higher degree polynomial, so we're going to go ahead and set it equal to 0. So I'm going to go ahead and subtract x cubed from both sides. And then I'm also going to subtract 7 on both sides. And that way we get it set equal to 0. All right, x cubed minus x cubed cancels as well. So I'm left with 3x squared plus 3x minus 6. And I see that they're all divisible by 3. So I'm going to divide 0 by 3. I get 0. 3 divided by 3 is 1. 3 divided by 3 is 1. 6 divided by 3 is 2. Okay. And that just kind of makes it easier to do my factoring. X times x to make x squared. My signs have to be different. And I'll do 2 here and -1 there. Okay. Take each factor. Set it equal to 0. Solve. So x equals -2. Add 1. X equals to 1. But we have to check. All right, so let's check x equals -2. So let's plug it back into the original problem. I'll use a cube root instead of the fraction. Okay, so it's -2 to the third power plus 7. We want to know, does this equal -2 plus 1? So let's find out. Okay, so in here, -2 to the third power is -8. Over here on the right side, -2 plus 1 is -1. And then over here, -8 plus 7 is -1. So remember, we're checking to see if both sides are the same. Are they equal? Okay, so here on the left, we get -1. On the right, we still have -1. Cube root of -1 is -1. And so, yes, the left does equal the right. And so -2 is an answer. Let's go ahead and check, what was our other one? +1. All right, so cube root 1 to the third power plus 7. And we want to know, does this equal to positive 1 plus 1? All right, so on the left side, we get 1 plus 7. And here I get 2. Over here, I get 8. And cube root of 8 is 2. So yes, 2 equals 2. So both of these answers right here are good. Okay, so that one and that one both work. Okay. All right, very good. And let's take a look at fourth root. So that was cube root. So we see here solving the cube root. We use the power 3 to cancel out the cube root. So let's look at fourth root. So of course, we're going to use the power 4 to cancel out the fourth root. Okay, so let's take a look. So you might have a question that's formed like this, and it looks really strange, and it might seem really confusing. So let me just show you what they mean. It's basically just solving. All right, so it might say something like this: f of x equals fourth root of 2x plus 1. Okay, and then it'll say for what values, value or values of x is f of x equal to 5. So they're basically saying, solve this equation, set it equal to 5 and solve it. Okay, so that's what they're saying. So they're saying, take this here, set it equal to 5 and solve. Okay. All right, so the radical is by itself. So I'm going to go ahead and use the power 4. And that will cancel out the radical. Okay. And then here I have 2x plus 1. And 5 to the fourth power is 625. Okay. Solving, subtract 1 on both sides. 2x is equal to 624. Divide both sides by 2. And x is equal to 312. 312. Okay, so let's go ahead and check this. I'll check over here on the side. All right, so 312. So fourth root, 2 times 312 plus 1. Does that equal 5? All right, so we have fourth root. That's 624 plus 1. And then this is fourth root of 625. And the fourth root of 625 is 5. So yes, this does work. X equals 312. Okay. Okay, so let's take a look and see what happens if you have two radicals. Okay, so so far, all of the equations have only had one radical to get rid of. If you see here, just the one radical, right? Just the one radical. And over here, just the one radical. And same thing here. Okay, so if we look back here, it says isolate the radical, square both sides, or n power, and then repeat the process until all radicals are gone. Okay, so if we have two radicals, we're going to go ahead and get rid of one at a time, okay, by doing this process over and over and over again. Okay, all right, so let's take a look at two radicals. Okay, so let's solve square root 5x plus 9 equals 2 times 3x plus 4. Okay, let me write it down here. Okay, so here we have two radicals. This one is isolated, so I can go ahead and do my power. So I'll square that, and then I have to square the other side, and that will get eliminated. Okay, so we eliminate that. Okay, so I get 5x plus 9 on this side. And on this side, careful, don't forget to square the 2. 2 gets squared, so that's 4. And then this gets squared, but then that ends up canceling its square root. So I'll just put this in parentheses. Okay. And then now we can just solve this as usual. All right, 5x plus 9 equals 12x plus 16. I'll go ahead and subtract 5x. So I get 9 equals 7x plus 16. Subtract 16. And we get negative 9. I mean, negative 7. Okay, so negative 7 equals 7x. And then divide both sides by 7. And we get x equals to negative 1. All right, so let's check this. Negative 1, negative 1, negative 1. Okay, so let's check up here. X equals negative 1. All right, so let's go up here to the original problem. Square root 5 times negative 1 plus 9. So that's the left side. And then the right side, 3 times negative 1 plus 4. Okay, so we want to know, is the left equal to the right? Okay, so over here we get negative 5 plus 9. And over here we get negative 3 plus 4. Okay, left side we get square root 4. Right side we get 2 times square root 1. Square root 4 is 2. And this is 2 times 1. So 2 equals 2. So yes, the left side does equal the right side. So x equals negative 1 is a solution. Okay, so that one wasn't too bad because when we got rid of one radical, we actually ended up getting rid of both of them. Okay, so let's take a look at what happens when you have to actually do the process more than once to get rid of all the radicals. Okay, let's solve. Square root x plus square root x plus 2 equals 2. All right, so I'm going to go ahead and write it down here. So we have two radicals. So I'm going to go ahead and isolate one of these. Again, it doesn't matter which one. It's the same amount of work. Okay. All right. So I'm just going to go ahead and I'll move this one over and I'll isolate this. Okay. So let's go ahead and subtract square root x. All right. So I've isolated this radical, square root of x plus 2. It's by itself on the left. And on the right-hand side, I have that binomial. Okay, so we're going to have to get rid of one radical at a time. I'm going to get rid of this one first, and then whatever, and then we'll see what we get, and then I'll get rid of the next radical after that, okay? All right, so I'm going to go ahead and get rid of this by squaring. I'm going to go ahead and do this by squaring. Okay, so I get x plus 2 over here on the left, and on this side, okay, so you might have to go off to the side and multiply out this binomial. Okay, I'm going to use the shortcut. So 2 squared is 4, minus 2 times 2 is 4, square root x, and then plus x. Okay, so when you do all of this off to the side, you should get this trinomial. If you don't, go back and do it again. Okay, so I still have a radical left, okay, which is usually the case. So then I'm not really ready to solve yet. I have to isolate the radical and then eliminate it. Okay, so I need to get this by itself. So I'm going to subtract 4 on both sides. Okay. So, and I'm also going to subtract x on both sides. Okay. Because I'm trying to isolate this. Okay, so I got to get rid of these guys. Okay. And I'm subtracting x on both sides. Okay. So that works out nicely. So then here I end up with -2 equals -4 square root x. Okay. Some people will go ahead and really fully isolate the radical. So they would do one more step and divide both sides by -4. That's fine. You can do that. Or you could just go ahead and square right off the bat right here. Just don't forget to square the -4. Okay. All right. So let's go ahead and do that. Let's go ahead and you know what? Let me be true to what I said. Let's divide both sides by -4. Let's fully isolate the radical. So here I get +1/2. Okay. And now I can go ahead and square both sides, right? And I need to square this side. And I end up with 1/4. 1/4 equals to x. So let's go ahead and let's check. I didn't really leave any room. I'm going to erase this. Okay. That way we can check over here on the side. And we said x equals what? 1/4. Okay. All right. So let's plug in 1/4 into the equation. 1/4 plus 1/4 plus 2. And we want to know, do we get 2? Does the left side equal the right side? Okay, so here, square root of 1/4 is actually 1/2. And then over here, that's 2 1/4. We want to know, do we get 2? All right, so 1/2 plus, this is the same as 9/4, because different ways to do this. If you want to get the LCD, put this over 1, get the LCD and add them, that's fine. I already know it's going to equal 2 1/4. And then I'm going to do 2 1/4. So I'm going to turn this into an improper. 4 times 2 is 8, plus 1 is 9. And we want to know, are we going to get 2? All right, so we get 1/2 plus square root of 9/4 is 3/2. So here we get 4/2. 4/2 is the same as 2. So yes, that works. So 1/4 is a solution. Okay. All right. So that is it. Okay. So that is it. If you have any questions, make sure you text me or you email me.